Good evening, students. Regarding yesterday's class notes, I'll ask them to upload. If it is not upload, definitely it will be uploaded by tomorrow. So I'll ask them to upload today itself. Notes will be uploaded. Don't worry. I'll talk to them regarding your notes uploading today. Write down next problem. The value of integral e to the power of 3z by z minus pi I dz, where C is the ellipse modulus of z minus 2 plus modulus of z plus 2 is equal to 6 is option A, option B, option C, option D. Remember, don't worry if you don't know how to draw the circle, because how to draw the ellipse, we were given the ellipse equation. So that's why don't worry, denominator is equated to 0. Whatever the z value you get, that is called a singular point. Substitute the singular point in the given closed curve. Resulting answer less than right side number, it is lying inside. Resulting answer greater than right side number, lying outside. The only thing that we need to do is, first of all, substitute your singular point in the given closed curve. Whether it lies inside or outside, we need to check. Write down. Denominator is equated to 0. We are getting z is equal to pi I is a singular point. Substitute z is equal to pi I singular point in the given closed curve. Z minus 2 plus z plus 2 is equal to 6. So z value pi I. Substitute z is equal to pi I here. I will go to the next slide. Z value pi I. So this is modulus of pi I minus 2 plus modulus of pi I plus 2. We don't know whether it is greater than right side number or less than right side number. Simply write right side number. Whether it is greater than right side number or less than right side number, we need to check. Magnitude of one complex number is square root of real part whole square plus imaginary part whole square. Magnitude of one complex number is square root of real part whole square plus imaginary part whole square, 6. I think it is greater than, you can verify. Root of pi square means 3.14 whole square, approximately 10 plus 4. And again this is root of pi square approximately 10, that is 2 square is 4. And you observe this is root to 10 approximately, this is root 14 plus root 14, which is root 14. Root 14 means 3 point something, 3.5 something. 3.5 plus 3.57, which is greater than right side number. So the singular point lies outside the closed curve. If singular point lies outside the closed curve, by Cauchy's integral theorem, value of the integral 0. Singular point lies outside the ellipse. Therefore, by Cauchy's integral theorem, we have integral e to the power of z by z minus pi I dz is equal to 0. Next slide. Most of the students have a doubt regarding one of the problem I gave yesterday. That problem, it can be solved using integral formula, but it is very complicated. So that type of problems can be solved very easily by using Cauchy residue theorem. So that problem, e power z by z square plus pi square whole square, I can again teach in Cauchy residue theorem. Using Cauchy residue theorem, that's very, very easy as compared to integral theorem or integral formula. So you wait until then. Next, the value of integral e to the power of z by z plus 1. This is the first page of today's class. This is the second page. This is the next page. Whole power 4 dz, where c is the circle mod z is equal to 2 is problem number 11. The value of integral sin hz by z power 4 dz, where c is the circle mod z is equal to 2 is 11th problem answer. Pi I by 3. Now 10th problem let me teach. 10th problem let me teach. Next slide. So center of the circle 0 0. Circle equation in complex variables is modulus of z minus z naught is equal to r. Z naught is the center, r is the radius. So this is mod z is equal to 2 circle. This is the center 0 0. And if radius 2 from center to here, we have 2 units. If radius 2, this is the point 0 comma minus 2. This is the point minus 2 comma 0. This is the point 0 comma 2. Denominator is equated to 0. Z plus 1 is equal to 0. Z is equal to minus 1. Z is equal to minus 1 is a singular point. Every complex number should also be written as a point form. This can be written as minus 1 plus I into 0. Real part x coordinate, imaginary part y coordinate. So minus 1 comma 0 will be here. The singular point lies inside the closed curve. Apply Cauchy's integral formula. But we need to apply the second version of Cauchy's integral formula. Anyhow, you should be careful. E power z dz by z plus 1 whole power 4. one or more singular points inside the closed curve, we need to apply Cauchy's integral formula. We are applying this is e power z by z plus 1 whole to the power of 4 can now be written as z minus of minus 1. Z minus of minus 1 whole power 4. Whole power 4 can be written as 3 plus 1. Whole power 4 can be written as 3 plus 1. So please do remember all of the formula I gave. Second version of Cauchy's integral formula, that is integral f of z by z minus z naught. Integral f of z by z minus z naught whole to the power of n plus 1. Integral, this is f of z by z minus z naught whole power n plus 1. My request to everybody, please remember the formula. I can directly apply here. Formula is 2 pi I into f power n of z naught by n factorial. This is the formula. So this is equal to 2 pi I into f power n means f power 3. F to the power of 3 means 3 times the differentiation of f of z naught means f of minus 1 by n factorial, that is 3 factorial. Now f power 3 means 3 times the differentiation of f of minus 1. In the margin of your notebook, please write this f of z. F of z is equal to e to the power of z. F of z is equal to e power z. So please remember everyone, one time differentiation, two times the differentiation, three times the differentiation, n times the differentiation of f of z of e power z is e power z only. So 3 times the differentiation of f of z is e power z only. But we need f power 3 of minus 1. This value means 3 times the differentiation of f of minus 1. That is e to the power of minus 1. So f power 3 of minus 1 is e power minus 1. So this is 2 pi I will write in the next slide. This value 2 pi I. 2 pi I into f power 3 of minus 1, that is e power minus 1, 3 factorial. Denominator 3 factorial is 6. So now 2 ones, 2 threes. And that is pi I by 3 into e power minus 1. Similarly, do this problem, same problem. The value of integral e to the power of 2z by z plus 1 whole power 4 dz. Where C is the circle, mod z is equal to 2 is. Try yourself it later. Answer 8 pi I by 3 e power minus 2. I will teach one more problem and we will go to the next model. Let f of z is equal to sigma n is equal to 0 to 15 z to the power of n, and c is modulus of z minus I is equal to 2. Full stop. The value of the integral f of z by z minus I whole to the power of 15 dz is. Remember, center of the circle is I. Z minus Z naught is equal to R. Z naught is the center, R is the radius. So center of the circle is I. Every complex number should also be written as point form. So real part x coordinate, imaginary part y coordinate. And radius of the circle is 2. Moreover, we were given f of z is equal to sigma n is equal to 0 to 15 z power n. Take n is equal to 0, z power 0, n is equal to 1, z power 1, z power 2. Take n is equal to 14, then it is z power 14. Take n is equal to 15, z to the power of 15. Let us take the given problem now. Going to the next slide. Remember, center of the circle at 0, 1 and radius is 2. On y-axis, here x coordinate 0. Center of the circle 0, 1 whose x coordinate 0. On y-axis only x coordinate will be 0. So center of the circle will lies on y-axis. Center of the circle at 0, 1. Center of the circle at 0, 1, radius 2 means from center 2 units down. From center 2 units down. This is 0, 1. Two units down means 0, 1, 0, 0, 0, minus 1. From center 2 units up, 0, 1, 0, 2, 0, 3. This is 0, 3 because center of the circle 0, center of the circle 0, 1 and radius is 2. That's why. Now, what is the singular point? Z is equal to I. I can be written as real part x coordinate, imaginary part y coordinate. Is a singular point. Z is equal to 0, 1 singular point will be center of the circle only. Z is equal to I means 0, 1 which is a singular point lying inside the closed curve only. So we need to apply Cauchy's integral formula. But Cauchy's integral formula second version is valid here. Integral f of z by z minus I whole to the power of 15 dz is equal to integral f of z by z minus I whole power 15 will now be written as 14 plus 1 into dz. Please cross check the second version of Cauchy's integral formula. That is f of z by z minus z naught whole to the power of n plus 1. F of z by z minus z naught whole power n plus 1. What is the formula? I have already used in the previous problem. That is 2 pi I into f power n of z naught by n factorial. I will write in the next slide. N value 14 and z naught value I. N value 14, z naught value I. Next slide. Two pi I into f power 14 of I divided by 14 factorial. Please remember everyone, we just need 14 times the differentiation of f of z. We need 14 times the differentiation of f of z. Let me check. 1 plus z square plus so on z power 4, z to the power of 14 plus z power 15. Now d power 14 by dz power 14 of f of z. Remember everyone, for one time derivative of z is 1. 2 times the differentiation of z square is 2z, 2 factorial. 3 times the differentiation of z cube, 3z square, 6z, 6. That is 3 factorial. So 4 times the differentiation of z power 4, 4 factorial. 5 times the differentiation of z power 5, 5 factorial. 14 times the differentiation of z power 14 will be 14 factorial. 14 times the differentiation of 1, 0. 14 times the differentiation of z, 0. 14 times the differentiation of z square, 0. 14 times the differentiation of z power 14 is 14 factorial. 14 times the differentiation of z power 14, 14 factorial. Because one time derivative of z, 1 factorial. 2 times the derivative of z square, 2 factorial. 3 times the differentiation of z cube, 3 factorial. 14 times the differentiation of z power 14, 14 factorial. And we just need 14 times the differentiation of z power 15. If anybody doesn't know, please follow me carefully. One time derivative of z square is 2z. 2 can be written as 2 factorial z. 2 times the differentiation of 2 times the differentiation of z cube. 3z square, 6z. 6 can be written as 3 factorial z. 4 times the differentiation of, 3 times the differentiation of z power 4. 4z cube, 12z square, 24z. 24z can be written as a 4 factorial into z. Now I will extend in this manner. Finally, 14 times the differentiation of z to the power of 15. One time derivative of z square, 2 factorial z. 2 times the derivative of z cube, 3 factorial z. 3 times the derivative of z power 4, 4 factorial z. 14 times the differentiation of z power 15, 15 factorial z. Be careful what I'm saying. 15 factorial, I can also write it as 15 into 14 factorial. 15 into 14 factorial z. Now go back. Now 14 times the differentiation of z power 15. That is 15 into 14 factorial z. 15 into 14 factorial z. Now 14 factorial is the common factor. So take out 14 factorial as common, then it is 1 plus 15z. 1 plus 15z. Have a look at the steps. Now this is 2 pi I by 14 factorial into f power 4. Sorry, we need one more step now. Sorry. This is d power 4 by dz power 4. That is, this is the value of 14 factorial. This is the value of 14 times the differentiation of f of z. That is 14 factorial into 1 plus 15z. Now take z is equal to I. F power 14 of I is equal to 14 factorial into 1 plus 15i. 1 plus 15i. So let us come back. F power 14 of I, that is 14 factorial into 1 plus 15i. So 14 factorial cancel. That would be 2 pi I into 1 plus 15i. Thank you. Note this and try yourself. The value of the integral one by 2 pi j into integral z plus 1 by z whole square dz. Evaluated over the unit circle mod z is equal to 1 is dash. And this problem given in the GATE Electronics Engineering 2019. Try yourself. Later, not now. Answer 0. Remember, practice as many different problems as possible regarding Cauchy's integral theorem, Cauchy's integral formula, Cauchy residue theorem. There must be a 2 marks problem every year in the GATE. I mean, almost every year from these 3 theorems. Let us go to the next topic. Taylor series. So what type of functions can be expanded as Taylor series? From complex variables, not from calculus. Remember everyone, any function which is analytic inside the circle, any function which is analytic everywhere inside the circle with the center at Z0 and radius R, then that function can be expanded as a Taylor series in powers of z minus z naught. I mean in positive powers of z minus z naught. Any function which is analytic at all points inside the circle with the center at z naught and radius r, then it should be expanded as a Taylor series in positive powers of z minus z naught, where z naught is the center of the circle. Theorem statement: if f of z is analytic, inside the circle with the center at z naught and radius r, then for all z inside C, inside C means inside the circle, f of z is equal to f of z naught plus z minus z naught into f dash of z naught plus z minus z naught whole square by 2 factorial into f double dash of z naught plus so on. Remember, I want to write this Taylor series in summation form, sigma notation form. I will write in the next slide. Next slide. Please write this series in summation form. F of z is equal to sigma n is equal to 0 to infinity f power n of z naught by n factorial into z minus z naught whole to the power of n. So everyone please do remember that here f to the power of n, n means n times the differentiation of f of z at z naught. F power n of z naught means n times the differentiation of f of z at z naught. If I take n is equal to 0, 0 times the differentiation of f of z naught, that is f of z naught only, first term. Yeah, 0 factorial 1, z minus z naught power 0 also 1. If I take n is equal to 1, you will get the second term of the series. That is z minus z naught power 1 by 1 factorial into f power 1 of z naught. If you take n is equal to 2, you will get the third term of the series. Third term of the series when you take n is equal to 2. Now I can write f of z is equal to sigma n is equal to 0 to infinity. This f power n of z naught by n factorial, let it be an. F power n of z naught by n factorial value, let it be an. Small a suffix n into z minus z naught whole to the power of n. Where an is equal to f power n of z naught by n factorial is equal to 1 by 2 pi I into f of z by z minus z naught whole to the power of n plus 1 dz. Please remember that why this f power n of z naught by n factorial value is equal to 1 by 2 pi I into integral f of z by z minus z naught whole power n plus 1. Let me check. Listen to me. Just rough calculation. Look here. Cauchy's integral formula second form. Cauchy's integral formula second form. This 2 pi I into f power n of z naught by n factorial. This is Cauchy's integral formula second form. Now here 2 pi I is there, no? That 2 pi I will go left side denominator, then it becomes 1 by 2 pi I into integral f of z by z minus z naught whole to the power of n plus 1 dz is equal to f power n of z naught by n factorial. This is Cauchy's integral formula second version, second form. I have just taken 2 pi I to the left side. Now f power n of z naught by n factorial is equal to this. The same thing only I have written here. F power n of z naught by n factorial is equal to this 1 by 2 pi I into integral f of z by z minus z naught whole to the power of n plus 1. From this, I have written that. From Cauchy's integral formula only, I have written when you take z naught is equal to 0, you will get a Maclaurin series. Taylor series about origin. Taylor series about origin, that is about z is equal to 0 is called Maclaurin series. That means in the previous Taylor series, substitute z naught is equal to 0. In the previous Taylor series, substitute z naught is equal to 0. Same Taylor series, but we have taken z naught is equal to 0. So f of z is equal to sigma n is equal to 0 to infinity. F power n of z naught value 0 by n factorial into z minus z naught. Nothing, I did not write anything. Same previous formula, substitute z naught is equal to 0. Here also substitute z naught is equal to 0. Here also, everywhere take z naught is equal to 0. So this f power n of z naught by n factorial, that is an into z power n, where an is equal to same formula, substitute z is equal to z naught. 1 by 2 pi I into f of z by z minus z naught whole power n plus 1 dz. Same previous statement, substitute z naught is equal to 0, that's it. Once again, listen to me. Any function which is analytic inside the circle with the center at z naught and radius r can be expanded as a Taylor series in positive powers of z minus z naught. Function must be analytic inside the circle with the center at z naught, radius r. Then it should be expanded a positive powers of z minus z naught. That series is called Taylor series. Now, Lorentz series. So, this outer circle, let it be C2, inner circle, let it be C1. Or outer circle, let it be C1, inner circle, let it be C2. Remember, both circles center same, Z naught. Both circles center same, Z naught. And radii different. The center of the bigger circle, the radius of the bigger circle is R1. Radius of the smaller circle is R2. Smaller circle radius R2, bigger circle radius R1. Bigger circle is C1, smaller circle is C2. Center of the circle at Z0. Circles having same center and different radii. Circles having same center and different radii are called concentric circles. Circles with same center and different radii are called concentric circles. The area between two concentric circles is called annulus. Annulus, also called annular region. Annulus, also called annular region or ring-shaped region. Annular region or ring-shaped region means area between two concentric circles. And be careful what type of functions can be expanded as a Lorentz series. This annular region, let it be capital R. Annular region, let it be capital R. Suppose any function which is analytic in the annular region, means suppose any function which is analytic between two concentric circles only, then that function can be expanded as a Lorentz series. Lorentz series means positive powers of z minus z naught and negative powers of z minus z naught. Taylor series means only positive powers of z minus z naught. Any function which is analytic in the annular region, that is between two concentric circles having center at z0 and radii r1 and r2, can be expanded a series of positive powers of z minus z0 as well as negative powers of z minus z0 That we call it as Laurent series. Theorem statement: if f of z is analytic in the angular region between two concentric circles with center at z0 and radii r1 comma r2. Remember, smaller circle radius r2, bigger circle radius r1. Smaller circle radius r2, bigger circle radius r1. Then for all z, then for all z in the region R, f of z is equal to sigma n is equal to 0 to infinity an into z minus z naught whole power n plus sigma n is equal to 1 to infinity an z minus z naught whole power minus n. Remember, positive powers of z minus z naught of the Laurent series is called regular part. Positive powers of z minus z naught of the Laurent series is called regular part, also called analytic part. Negative powers of z minus z naught of the Laurent series is called principal part. Principal part of the Laurent series means negative powers of z minus z naught. Regular part of the Laurent series means positive powers of z minus z naught. Where an is equal to 1 by 2 pi I into same Taylor series an only. Now, before going to solve the problems on Laurent series and Taylor series, please remember some of the standard formulas that we are very familiar. We have already learned from the lower classes. Yes, it is Bn. One is An, second one is Bn. By mistake, 1 minute students, by mistake I have written An here. By mistake I have written an here. It should be bn. Bn, Bn, this one, principal part Bn. Next, some standard series why you are getting confused, I don't know. Where is C, man? C1 means bigger circle, C2 means a smaller circle. So here C means, okay, do one thing. Okay, fine, fine. Simply C means, I will let you know what is C. C means this red colored shaded area. C means that red colored shaded area. That is C. In order to avoid confusion, do one thing. To avoid confusion, do one thing. Simply write integral. To avoid confusion, simply write integral. C means that shaded area, red colored shaded area, let it be C. It's a closed curve region. Some standard series expansions. We are very familiar with these formulas. 1 minus x whole power minus 1 formula, 1 plus x square plus x cube plus so on. It's a region of convergence. A region of convergence, or this formula is valid. Region of convergence means validity of the formula. Mod x less than 1. Remember, this formula is valid for all x values between minus 1 and plus 1 only. Mod x less than 1 means minus 1 less than x less than 1. That mod x less than 1 means whatever the formulas I am writing, no, those formulas are valid in such regions only. Mod x less than 1 means minus 1 less than x less than 1. For all x values between minus 1 and plus 1 only, these two formulas valid. Next one. This formula also valid in the region mod x less than 1. Even the next formula also valid in the same region. Minus x, logarithm of 1 minus x. Every term would be a negative term only. This is also valid in the region mod x less than 1. Next. X minus x cube by 3 factorial plus x cube by 5 factorial minus x power 7 by 7 factorial. Remember, as we discussed already in the previous classes, sin x is entire function. Entire function means analytic everywhere. Analytic everywhere means analytic differentiable continuous everywhere means it is analytic between minus infinity and plus infinity. It is analytic between minus infinity and plus infinity means mod x less than infinity means minus infinity less than x less than infinity only. Sin hx. Sin hx means same formula, all terms must be taken as positive. It is also entire function. So validity region is minus infinity to plus infinity. Cos x 1 minus x square by 2 plus x power 4 by 4 factorial minus x power 6 by 6 factorial. So this is also entire function. So validity region up to infinity. Cos hx means same formula, all terms must be taken as positive. Same formula, but all terms must be positive. Next. E to the power of x. This is also entire function. So its validity region should also be from minus infinity to plus infinity then. Similarly, e to the power of minus x formula alternately positive, alternately negative. 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus so on mod x less than infinity. This is the region. Now we do problems. Problem number 1. In the Taylor series expansion of e power z plus sin z about z is equal to pi, comma, the coefficient of z minus pi whole square is option A, option B, option C, e power pi by 3, option D, e power pi by 6. So please remember everyone, all of you please refer the coefficient of z minus z naught whole square. And everyone should remember the given function, let it be f of z. Suppose you want the coefficient of z minus z naught whole square, it is f double dash of z naught by 2 factorial. This is z minus z naught, z minus z naught whole square. So z naught value pi, coefficient of z minus z naught whole square in the in the Taylor series expansion should be f double dash of z naught by 2 factorial, where z naught value pi, where z naught value pi, please do remember. Now we need f double dash of z. So f dash of z is equal to e power z plus sin z derivative cos z. Similarly, f double dash of z is equal to e power z cos z derivative minus sin z. Z minus z naught whole square coefficient should be f double dash of z naught by 2 factorial. F double dash of z naught means f double dash of pi, f double dash of pi by 2 factorial. So f double dash of pi is equal to e power pi minus sin pi. Sin pi 0, so it is e power pi. Therefore, z minus z naught whole square coefficient is equal to f double dash of z naught by 2 factorial. That is e power pi by 2 factorial would be 2. And next. And everyone should listen to me carefully. Either it is a Taylor series or Lorentz series, whichever it is, whenever it is possible, listen to me. Where it is, wherever, whenever it is a Taylor series or Lorentz series, whichever it is possible, let us try to expand the given function as a Taylor series or Lorentz series with the help of these formulas whenever it is possible. With the help of these formulas, whenever it is possible. Problem number 2. And everyone listen to me. Taylor series cannot be expanded as a function, cannot be expanded as a Lorentz series by using Lorentz series formula. So any function can be expanded as a Lorentz series with the help of some standard series expansions only. Lorentz series, it is never possible to be expanded by using Lorentz series theorem or by using Lorentz series formula. All Lorentz series problems should be solved or should be expanded using some standard series expansion formulas only. Problem. The coefficient of 1 by z in the coefficient of 1 by z in the Lorentz series expansion of logarithm of z by z minus 1 valid for mod z greater than 1 is dash. Remember, you are asked to expand. You are asked to expand logarithm of z by z minus 1 in the Lorentz series expansion. Your Lorentz series expansion should be valid in the region mod z greater than 1. Mod z greater than 1. Don't use any Lorentz series formula to expand any given function as a Lorentz series. Any Lorentz series problems can be expanded by using some standard series expansions only. Our function is a logarithmic function, right? Our function is a logarithmic function. Now, series number 3, standard series 3 and 4. Standard series 3 and 4 are logarithmic functions only. So logarithmic functions valid in the region. Logarithmic functions valid in the region mod x less than 1. Modulus of x less than 1. Modulus of x less than 1. Now look here. What is given? You are given mod z greater than 1. And everyone should listen to me carefully. Your Lorentz series expansion should be valid in the region mod x less than 1. So it should be brought to the form of mod x less than 1. In place of x, you may have any variable, any variable. So I can write like this, 1 less than mod z. But our series should be valid in the region mod x less than 1. That's why to make it as less than 1, divide both sides by mod z. Then it is 1 by mod z. 1 by mod z. I will write 1 also inside the modulus because mod 1 is 1. So 1 by mod z, I will write 1 also inside the modulus. Modulus of 1 by z less than 1. Look here. Any logarithmic series expansion valid in the region mod x less than 1. Here mod x less than 1. What is x value? 1 by z. Mod x less than 1, x value 1 by z. What does it mean? We need series expansion in terms of 1 by z. Mod x less than 1, x value 1 by z. That means a series expansion required in terms of 1 by z. Series expansion required in terms of 1 by z. What is given? A logarithm of z by z minus 1. But what I said, series expansion required in terms of 1 by z. So that's why make this function as 1 by z. To make this function as 1 by z, take out z common. To make it as 1 by z, take z common from the denominator. Then it is z into 1 minus 1 by z. Z into 1 minus 1 by z. Now it becomes 1 by z. Just in order to make it as 1 by z, I took out z common from the denominator. Now it is logarithm of 1 by 1 minus 1 by z. This is a logarithm of a by b. Logarithm of a by b, formula logarithm of a. Logarithm of a by b formula log a minus log b. Log b. B means 1 minus 1 by z. As you people know, log 1 value 0. Next slide. This is 1 minus x. Please use logarithm of 1 minus x formula. Let it be 1 minus x. 1 by z, let it be x. Logarithm of 1 minus x. Minus into Logarithm of 1 minus x formula, minus x minus x square by 2 minus x cube by 3 minus so on. This is logarithm of 1 minus x formula. Now minus into minus 1 by z. This is 1 by z whole square, that is 1 by z square. Z square comes down, that is minus 1 by 2z square minus 1 by z cube. Z cube will come down, minus 1 by 3z cube. Multiply each and every term of the bracket function with minus 1, minus symbol. Minus into minus plus 1 by z. Minus into minus plus 1 by 2z square. Minus into minus plus 1 by 3z cube. Now you are asked to find the coefficient of 1 by z. What is 1 by z coefficient? 1. Next. Problem number 3. Always tricks will not work out. Sometimes we need to expand. This is not lengthy. 2-3 steps. Problem number 3. The Lorentz series expansion. The Lorentz series expansion of e to the power of 2z by e to the power of 2z by z minus 1 whole cube. About z is equal to 1 is you are asked to write very simple. You are asked to write the Lorentz series about z is equal to 1. Lorentz series cannot be expanded using Lorentz series formula. We only have to write a Taylor series or Lorentz series by manipulating or with the help of 10 formulas I gave whenever it is possible. I will show you. We were asked to write the Lorentz series about z is equal to 1. About z is equal to 1. Just for the sake of convenience, you simply assume z is equal to 1, because we need to expand the given function as a Lorentz series about z is equal to 1. So if 1 goes to left side, it becomes z minus 1. That means we need Lorentz series expansion in powers of z minus 1. So to get Lorentz series in powers of z minus 1, assume z minus 1 is equal to t. So z is equal to t plus 1. But we need e to the power of 2z now. But e to the power of 2z was there. So that's why 2z is equal to 2 into t. 2t plus 2 into 1, 2. See, whenever you don't know how to expand the function, simple logic I will let you know. You are asked to write the series about z is equal to 1. So assume z is equal to 1. If 1 goes to left side, that becomes z minus 1. So assume z minus 1 is equal to t. So z is equal to t plus 1. 2z is equal to 2t plus 2. So e to the power of 2z is equal to e to the power of 2t plus 2. So e to the power of 2z is equal to e to the power of 2t into e square. So remember this story. Just for the sake of convenience only, all the things not required, we just need first and second term only, this term and this term only. Remaining terms I have written just for our convenience. Now actually e to the power of 2z by z minus 1 whole cube. E to the power of 2z value already found here. That is e to the power of 2t into e to the power of 2. By denominator is z minus 1 whole cube. Z minus 1 value t cube. So e square constant out of the bracket, t cube also written out of the bracket. And all of you, please see formula number 9. Some standard series expansions, formula number 9. That is e to the power of x. Let it be x. E to the power of x. E power x. X value 2t. E power x, x value 2t. That is 1 plus x plus x square by 2 factorial plus x cube by 3 factorial plus so on. I will write in the next slide. Next slide. This is e to the power of x expansion. X means 2t. So e square by t cube 1 plus 2t 2t whole square, that is 4t square by 2 factorial, that is 2t square plus 2t whole cube, that is 8t cube. 8t cube divided by 3 factorial, 8t cube by 6. 8t cube by 6 means 2 4s 2 3s, that is 4 by 3 t cube plus so on. 4t square by 2 factorial, that is 2t square. So multiply each and every term of the bracket function with 1 by t cube. Then it is 1 by t cube, that is okay, plus 2t divided by t cube, that is 2 by t square plus 2t square divided by t cube, that is 2 by t plus 4 by 3 into t cube cancel plus so on. But actually, what is our assumption for t? Look there. Our assumption for t is z minus 1. Assumption for t, z minus 1. In place of t, substitute z minus 1. Problem number 4. The Taylor series expansion. Sorry. Problem number 4. Write like this. Expand z minus 3 into sine of 1 by z plus 2 about z is equal to minus 2. So we were asked to write the series about z is equal to minus 2. If minus 2 goes to left side, it becomes plus 2. That means we need series expansion in terms of z plus 2. We need series expansion in terms of z plus 2. So to get the series expansion in terms of z plus 2, assume z plus 2 is equal to t. So from this, z is equal to t minus 2. Moreover, we need z minus 3 because z minus 3 was there in your expansion. So that's why z minus 3 is equal to z value t minus 2 minus 3, that is t minus 5. Remember this story. Now take the given function. Z minus 3 into sine of 1 by z plus 2. Our assumption for z minus 3 is t minus 5. T minus 5. Sine of 1 by z plus 2. Z plus 2 means t. Z plus 2 means t. So sine of 1 by z plus 2, sine of 1 by t. T minus 5 into, we know sin x expansion. Sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial, so on. X means 1 by t. X minus x cube by 3 factorial plus x power 5 by 5 factorial. Now this would be t minus 5 into 1 by t as it is minus 1 by t whole cube, that is 1 by t cube. T cube will come down, that is 1 by 3 factorial into t cube plus 1 by t power 5. T power 5 will come down, 1 by 5 factorial into t to the power of 5 minus 1. Now let us write t into this bracket. That would be written in one bracket. Look there, t into 1 by t, 1. T into 1 by 3 factorial into t cube. 3 factorial value 6. T by t cube, 1 by t square. So minus 1 by 6 t square. Now 5 factorial value 120. T by t power 5. that is 1 by t power 4. That is 1 by 120 t to the power of 4 minus so on. Now second term, this minus symbol as it is, take only 5 into the bracket. Take only 5 into the bracket, that is a 5 by t. Next to 5 by 3 factorial, that is a 5 by 6 t cube. Next to 5 by 5 factorial, that is 5 by 4 factorial. 5 by 5 factorial means that is 1 by 4 factorial. 1 by 4 factorial is 24. 1 by t to the power of 5 minus so on. Let us write in a systematic order. Let us write in a systematic order. First term constant. Second term 1 by t terms. Next to 1 by t square terms. Next to 1 by t cube terms. And then so on. First constant. First constant, that is 1. Next to 1 by t. Next to 1 by t terms. Look here. 1 by t terms means minus into 5 by t. Minus into 5 by t. Next to 1 by t square terms. 1 by t square terms minus 1 by 6t square. Minus 1 by 6t square. Next to 1 by t cube terms, minus into this minus plus 5 by 6t cube. Next to 1 by t to the power of 4, that is plus 1 by t to 120 plus 1 by 120 t to the power of 4. Next 1 by t power 5 minus into plus minus 1 by 24 t power 5. Minus 1 by 24 t to the power of 5 plus so on. So this is 1 minus 5 by our assumption for t should be z plus 2. Minus 1 by 6 into z plus 2 whole square. 6 into t. T means z plus 2 whole cube. Plus plus 1 by 120 z plus 2 whole power 4 minus 1 by 24 into z plus 2 whole to the power of 5 minus so on. This is the way. In the similar manner, note this problem and try yourself. Problem number 5. The Taylor series expansion of z minus sin z by z power 5. About z is equal to 0. Remember, about z is equal to 2 means if 2 goes to left side, it becomes z minus 2. So we need our series expansion in powers of z minus 2. About z is equal to 0 means if 0 goes to left side, it becomes z minus 0. That means we need our series expansion in terms of z only. That means directly you write sin z expansion and simplify. Z minus first 1 by z power 5 out. Z minus write sin z expansion directly and simplify. The answer is 1 by 3 factorial minus z square by 5 factorial plus z power 4 by 7 factorial, so on. Try yourself it later. Next. In the Lorentz series expansion of f of z is equal to 1 by z minus 1 into z minus 2 valid in the region 1 less than mod z less than 2 yes previous problem denominator power 3 sorry this previous problem denominator power 3 sorry previous problem denominator power 3 the coefficient of 1 by z square is option A 0, option B 1 by 2, option C 1, option D minus 1. This problem engineering services examination 2018 prelims paper. Remember, whenever the statement of the problem does not contain transcendental function, means trigonometric, hyperbolic, logarithmic, exponential. Statement of the problem does not contain transcendental function means statement of the problem does not contain trigonometric, hyperbolic, logarithmic, exponential. In all such cases, that function can be expanded as a Taylor series or Lorentz series, whichever is possible, with the help of binomial expansion only. With the help of binomial expansion only. Binomial expansion valid in the region Binomial expansion means this first one and second one is a binomial expansion. So binomial expansion valid in the region mod x less than 1. Binomial expansion valid in the region mod x less than 1. So before going to solve your problem also, you need to get your region in the format mod x less than 1. Mod x less than 1. Now, what is the region given? Region given is 1 less than mod z less than 2. So I will split like this. It should be 1 less than mod z and mod z less than 2. 1 less than mod z and mod z less than 2. But what I said, our region should be in the format mod x less than 1, because the right side should be less than 1. To make it as less than 1, divide both sides by mod z. 1 by mod z. Write 1 also inside the modulus. Mod 1 by z less than 1. So mod x less than 1. So x value 1 by z. This should be mod x less than 1. To make it as less than 1, divide both sides by 2. Mod z divided by 2. Write 2 also inside the modulus, because mod 2 is 2 only. So mod x less than 1. Mod x less than 1. X value 1 by z. Look, x value 1 by z, x value z by 2. That means we need the series expansion in terms of 1 by z and z by 2. Mod x less than 1, x value 1 by z, and in the second case x value z by 2. That means the series expansion is required in terms of 1 by z and z by 2. Remember, that is important. Series expansion required now. Take the given function. Listen to me. Whenever you want to expand any given function as a Taylor series or Lorentz series, first of all, you need to split your function into partial fractions. If degree of numerator is less than degree of denominator, first split your function into partial fractions, and then only you need to expand your function as a Taylor series or Lorentz series, whichever is asked or whichever is possible. So that's why I want to split up into partial fractions. Suppose you people don't know the partial fractions, you can do like this. Addition or subtraction of the denominator two terms must be written in the numerator. The alternate method of partial fractions is addition or subtraction of denominator two terms should be written in the numerator in such a way that numerator value should not be changed. I want to subtract the denominator this term minus this term. Plus z minus z cancel. Minus 1 plus 2, that is 1. So numerator still 1 only. This is an alternate of partial fractions. Now split this fraction. Z minus 1 by z minus 1 into z minus 2. That is 1 by z minus 2 minus z minus 2 by z minus 1 into z minus 2, that is 1 by z minus 1. Listen to me carefully. We need the series expansion in terms of z by 2. We need a series expansion in terms of z by 2. Z by 2. To get the series expansion in terms of z by 2, here minus 2 will be taken out. To get the series expansion in terms of z by 2, minus 2 will be taken out. Then it will become z by 2. Minus 2 into 1, minus 2, minus 2 into minus z by 2, that is plus z. But some people have a doubt. 1 by 2 now. What is this? Everything is fine. Plus z minus z, 2 minus 1, everything is correct. So minus 2 into 1, minus 2, minus 2 into minus plus, 2 cancel z. Now some people have a doubt that, sir, to make it as in powers of z by 2, why can't we take out 2 as a common factor instead of minus 2? So please be careful. If you take out 2, then this bracket function cannot be brought to the form of 1 plus x or 1 minus x. If this bracket function cannot brought to that 1 plus x or 1 minus x form, then how can you apply binomial expansion like 1 minus x a whole power minus 1 or 1 plus x a whole power minus 1? It's impossible. So that's why you need to take out minus 2. Minus 1 by, be careful, we need a series expansion in terms of 1 by z, 1 by z, 1 by z. To make it as 1 by z, z will be out, z will be out. 1 minus 1 by z. So 1 by minus 2, that would be minus 1 by 2. Take the denominator in the numerator. 1 minus z by 2 whole power minus 1 minus 1 by z into, take this denominator function in the numerator, 1 minus 1 by z power minus 1. And now we were given, I hope you people might have remembered the formula, 1 minus x a whole power minus 1 formula, 1 plus x square plus x cube plus so on. Now this is x. This is x. Now this is minus 1 by 2 into 1 minus x a whole power minus 1. That is 1 plus x plus x square plus so on. Similarly, the second bracket is also 1 minus x whole power minus 1. That is 1 plus x plus x square. I will write in the next slide. Next slide. F of z is equal to minus 1 by 2 into 1 plus z by 2 plus z by 2 whole square so on minus. See, Take this minus 1 by z inside the bracket. Take complete minus 1 by z into the bracket. Minus 1 by z into 1. Minus 1 by z. Minus 1 by z into plus 1 by z. Minus 1 by z square. Minus 1 by z into plus 1 by z whole square. Minus 1 by z cube. Minus so on. You are just asked to find the coefficient of 1 by z square. Coefficient of 1 by z square is minus 1. So option D is the right answer. Coefficient of 1 by z square is minus 1. Same problem can also be expanded in the GATE examination or engineering services examination will be like this. Same should also be expected like this in the exam. Expand 1 by z minus 1 into z minus 2 valid for mod z less than 1, mod z greater than 2. Actually, previous case is 1 less than mod z less than 1. Sorry, 1 less than mod z less than 2. Now this case I can ask you mod z less than 1 and mod z greater than 2. The previous problem can also be expected like this in the examination. After expecting like this, in this case also you may be asked to find the coefficient of 1 by z or 1 by z square, something like that. That is what I'm saying. Whenever the statement of the given problem does not contain trigonometric or hyperbolic or logarithmic or exponential, in all such cases, we need to expand the given function as a Taylor series or Lorentz series, whichever is possible, with the help of binomial expansion. Binomial expansion is valid in the region mod x less than 1. 1 minus x whole power minus 1 or 1 plus x whole power minus 1 will be valid in the region of mod x less than 1. Please keep it in the mind. You are given mod z less than 1. So write down mod z less than 1. And you should be careful. You are given mod z less than 1. No, I will write 1 less than 2. You are given mod z less than 1, right? So I can write mod z less than 1, then 1 less than 2. You people have a doubt that why did I write 1 less than 2? If you want, you can write, why can't we write 1 less than 3, 1 less than 4, 1 less than 5, etc., etc. Look here. Here the second function is z minus 2. That's why 1 less than 2. Suppose the second function is z minus 3, it should have been 1 less than 3. If it is z minus 10, it should be 1 less than 10. What are the regions now? Mod z less than 1 and second one is mod z less than 2. Mod z less than 1 and mod z less than 2. But we are going to expand our function using the binomial expansion, that is 1 minus x whole power minus 1, because the statement of the given problem does not contain trigonometric or hyperbolic or logarithmic or exponential. All the type of functions must always be expanded using binomial expansion of 1 minus x or 1 plus x whole power minus 1. But all the type of binomial expansions valid in the region mod x less than 1. Now target mod x less than 1. It is already mod x less than 1. X means z. This is mod x, but it is not less than 1. So to make it as less than 1, divide both sides by 2. Divide both sides by 2. Mod z by 2. Write 2 inside the modulus. Mod z by 2 less than 1. Mod x less than 1. X value z by 2. Mod x less than 1. X value z by 2. Mod x less than 1. X value z. That means we need series expansion in terms of z and z by 2. We need series expansion in terms of z and z by 2. Please remember. Now f of z is equal to 1 by z minus 1 into z minus 2. Simplified form of 1 by z minus 1 into z minus 2 was already written in the previous problem itself. Have a look here. 1 by z minus 1 into z minus 2. Simplified form is 1 by z minus 2 minus 1 by z minus 1. One by z minus 2 minus 1 by z minus 1. Now we need the series expansion in powers of z by 2. In powers of z by 2. So we should make this z as z by 2, because series expansion should be required in powers of z by 2. See this highlighted part in red color, z by 2. To get it in the format of z by 2, you people have a doubt that 2 will be taken out as common. But you should not take out 2 common. You have to take out minus 2 common, because when you take out minus 2 as a common factor, then only the remaining part should be brought to the form of 1 minus x or 1 plus x whole power minus 1. That's why this is 1 minus z by 2. Now we need our series expansion in terms of z by 2 and z only. This first term z only. But binomial expansion should be in the form of 1 minus z, 1 plus z. So that's why I want to write this z minus 1 as 1 minus z. For that, I have to take out minus symbol. Minus symbol into 1 minus z. 1 by minus 2. That is minus 1 by 2. And take out 1 minus z by 2 in the numerator. Take out 1 minus z by 2 in the numerator. Power minus 1. Next, this minus into this minus plus, and take that 1 minus z in the numerator becomes whole power minus 1. Let it be x. Let it be x. 1 minus x whole power minus 1 formula I have already given in the previous problem. That is 1 plus x plus, this is 1 minus x whole power minus 1. That is 1 plus x square plus x cube plus so on. That's it. In the examination, you may be asked to write the coefficient of z or coefficient of z square, whatever it may be. Then we can simplify and write. Now, the next case is when mod z greater than 2. We are doing second problem. Mod z greater than 2. I can write mod z greater than 2 and I will write 2 greater than 1. You are given mod z greater than 2, but I have written 2 greater than 1. You people have a doubt that why did I write 2 greater than 1 even though we were given only z greater than 2. Z greater than 2 was given, but I wrote to 2 greater than 1. Reason behind here, another function is z minus 1. Here another function z minus 1. That's why I wrote to 2 greater than 1. Suppose it is z plus 1, means z minus of minus 1. Then it should have been 2 greater than minus 1. Suppose it is only z minus 0, I should write 2 greater than 0. Please be careful what I'm saying. Now, this is mod z greater than 2 is okay, and the second one is mod z greater than 1. That is what I'm saying. Statement of the given problem does not contain trigonometric or hyperbolic or logarithmic or exponential. In all such cases, the given function can be expanded either a Taylor series or a Laurent series, whichever is possible, with the help of binomial expansion. Binomial expansion valid in the region mod x less than 1. So our target, our region should be in the form of modulus of x less than 1. In place of x, we may have anything. So mod z greater than 2, I can write 2 less than mod z because trying for mod x less than 1 format. Mod z greater than 1 should be written as 1 less than mod z. Target mod x less than 1. To make it as less than 1, divide both sides by mod z. 2 by mod z. 2 by mod z less than 1. I will write 2 also inside the modulus because mod 2 is 2 only. Now to make it as less than 1, right side to make it as less than 1, divide both sides of this equation by mod z. 1 by mod z. I will write 1 also inside the modulus. Less than 1. So this is mod x less than 1. This is also mod x less than 1. So we need our series expansion in terms of 1 by z and 2 by z. Series expansion required in terms of 1 by z and 2 by z. Two functions are there. This is the first function. This is the second function. Two functions are there. That's why two regions required. Suppose you have three functions here, then we need three regions. Please be careful. Write down. F of z is equal to 1 by z minus 1. Break will be given. You must have patience coming to the classes only for the breaks. Need not raise the hand, I know. Let me complete this problem. This is 1 by z minus 2 minus 1 by z minus 1. Now we need series expansion in terms of 2 by z and 1 by z as well. How can you make it as 2 by z? Z will be out. Z into 1 minus 2 by z. We need series expansion in terms of 1 by z. So to make it as 1 by z, z will be out. Z into 1 minus 1 by z. Take the denominator in the numerator. Then it is 1 minus 2 by z power minus 1 minus 1 by z into 1 minus 1 by z power minus 1. This is 1 minus x whole power minus 1, 1 minus x whole power minus 1. So that is 1 plus x plus x square plus so on minus 1 by z into 1 plus x plus x square plus so on. Need not simplify. Based on the options, we need to simplify. So I just give you a problem and then try yourself. Just 2 minutes, I will give the break. Problem completed. Note this and try yourself. If f of z is equal to z by z plus 1 into z plus 2, then the Laurent series expansion of f of z see, I did not 1 by z will cancel. I did not simplify. In this step, plus 1 by z minus 1 by z may cancel. I did not simplify. I have left like that. In the exam, based on the options, you need to simplify. That's fine, no issue. If you want, you can simplify. That's it. Then f of z about z is equal to minus 2 is, listen to me, either it is a Taylor series or Laurent series, no issue. If degree of numerator is less than degree of denominator, degree of numerator is less than degree of denominator, before going to expand, first you need to split your function into partial fractions. I hope you people know partial fractions. First to split into partial fractions and then expand the way I have earlier taught. This is not the region. This is the series expansion required about z is equal to minus 2. About z is equal to minus 2. If minus 2 goes to left side, it becomes z plus 2. That means we need our series expansion in powers of z plus 2. So to get our series expansion in powers of z plus 2, assume z plus 2 is equal to t, assume z plus 2 is equal to t, and then proceed further. Proceed further. We will continue after the break. Thank you for your patience. Let's continue after the break. So welcome back to the session. Let us start another topic. Classification of singularities. Classification of partial fractions required only when degree of numerator is less than degree of denominator. Suppose degree of numerator is equal to degree of denominator. In such cases, directly substitute the assumption and proceed further. First definition, isolated singular point. Isolated singular point. First, I will explain with an example before going to discuss about its definition. Let me explain with an example. Example, consider, after this example, you will be able to understand what is isolated singular point. Consider the complex valued function f of z is equal to 1 by z minus 1 into z minus 2 into z minus 3. So denominator is equated to 0. Whatever the z values you get, these z values are called singular points. Remember, when one singular point is called isolated singular point, that case we are discussing right now. So, very simple to identify. This is y-axis, this is x-axis. Now this is z is equal to 0. This is z is equal to 1. This is z is equal to 2. Similarly, z is equal to 3 also. Let us consider z is equal to 2. This is z is equal to 3. Remember, to consider one singular point is isolated or non-isolated singular point, you need to consider the neighborhood of that point. Now I want to verify whether one is isolated or non-isolated singular point. So I am considering a neighborhood of 1. Neighborhood of 1. Similarly, to consider whether 2 is isolated or non-isolated singular point, consider neighborhood of 2. Similarly, consider neighborhood of 3. Do you know neighborhood of 1 means? Neighborhood of a point 1 means center of the circle 1, radius of the circle very nearer to 0 but not 0. Neighborhood of 1 means center of the circle 1, radius of the circle is very nearer to 0 but not 0, like 0.0001. Now center of the circle 1, radius of the circle 0.0001. Now be careful what I am saying regarding isolated singular point. Suppose z is equal to 1 is a singular point of the given function, and all other singular points of the same function will lie outside the neighborhood of 1. All other singular points of the same function will lie outside the neighborhood of 1. Outside the neighborhood of 1. Because center of the circle is 1. Radius of the circle is 0.0001. So therefore, if center 1 from here to here, we have 1.00001. So obviously, if you continuously raising hands without concentrating, you cannot understand, I guarantee. Suppose 1 is the center of the circle, radius is very nearer to 0 but not 0, then other singular point to 2 will lie outside the neighborhood of 1. Why other singular point to 2 will lie outside the neighborhood of 1? Because center of the circle is 1, radius very nearer to 0 but not 0. Radius of the first circle is very nearer to 0. That's why second and third singular points, 2, 3 singular points will lie outside the neighborhood of 1. Therefore, 1 is isolated singular point. Similarly, to check whether 2 is isolated or non-isolated singular point, consider the neighborhood of 2. Center of the circle is 2. Radius of the circle very nearer to 0 but not 0. So obviously the singular point 1 and 3 will lie outside the neighborhood of 2, because center of the circle 2, radius of the circle 0.001. That's why 1 and 3 will lie outside 2. Therefore, 2 is isolated singular point. In this similar manner, 3 is also isolated singular point. Therefore, z is equal to 1, comma 2, comma 3 are called isolated. Are called isolated singular points. What do you mean by isolated singular points? Suppose z is equal to z naught is a singular point of the function. Suppose z is equal to z naught. Z naught means 1. Suppose z is equal to z naught is a singular point of the function. Other singular points of the same function. Other singular points of the same function means 2 and 3 will lie outside the neighborhood of 1. Will lie outside the neighborhood of 1 means will lie outside the circle of 1. Then 1 is called isolated singular point. What I said, if z is equal to z naught is a singular point of the function and all other singular points of the same function will lie outside the neighborhood of z naught is isolated. Non-isolated means, see, all other singular points will lie outside the neighborhood of 1. 1 is isolated. One or more other singular points of the function will lie inside the neighborhood of 1. 1 is non-isolated. Definition. If z is equal to z naught is a singular point of the function f of z, and there are no other singular points, singularities. Singularities means singular points, and there are no other singularities, and there are no other singular points in the neighborhood of z naught then Z naught is called isolated singular point. Then Z naught is called isolated singular point. Now, let us write the definition of a non-isolated singular point. Isolated singular point example already written we have. Next, non-isolated singular point. No singular, suppose Z naught is a singular point, no other singularities inside the neighborhood of Z naught is isolated. One or more other singularities inside the neighborhood of Z naught, then Z naught is non-isolated singular point. Write down. If Z is equal to Z naught is a singular point of the function f of z, and there are no other, and there are one or more other singularities, one or more other singularities inside the neighborhood of Z naught, then Z is equal to Z naught is called a non-isolated singular point. A non-isolated singular point. We see an example. One or more other singular points of the same function will lie inside the given neighborhood of Z naught. Z naught will be non-isolated. Consider example. Consider f of z is equal to 1 by tan pi by z. See, up to decide what point of neighborhood means, Delta neighborhood. Delta value means any number very nearer to 0. 1.00001. Minimum 2 zeros must be required. Look, I want the singular points. To get the singular points, simply denominator is equated to 0. To get the singular point, simply denominator is equated to 0. I think you people know tan theta is equal to 0. So theta is equal to n pi. N belongs to integers. In trigonometry basics, tan theta is equal to 0, theta is equal to n pi. Here theta value pi by z. Theta value pi by z. Tan theta is equal to 0. So theta is equal to n pi, where n belongs to integers. Integers means 0 plus or minus 1 plus or minus 2 plus or minus 3, so on. 1 pi cancel. So from this, 1 by z is equal to n, where n is integer. So from this, z is equal to 1 by n, where n cannot be 0. If n is 0, 1 by 0, infinity means undefined, means problem fails. N is not equal to 0, and at the same time, n is an integer. Now, n is integer means plus or minus 1, plus or minus 2, so on. If I take n is equal to plus or minus 1, then it should be plus or minus 1. Take n is equal to plus or minus 2, then z value plus or minus 1 by 2. Take n is equal to plus or minus 3, then it is 1 plus or minus 1 by 3, plus or minus 1 by 4. N is equal to plus 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. What is the largest value of n? Largest value of n, largest value of n, 1 crore, 10 crores, 1000 crores, 1 crore crores. The biggest value of n is infinity. If I take n is equal to infinity, 1 by infinity, that is 0. Now, I just want to know whether z is equal to 0 is an isolated singular point or non-isolated singular point. I just want to confirm z is equal to 0 is isolated or non-isolated singular point. For that, you need to identify neighborhood of z is equal to 0, 0. Among all singular points, I just want to confirm whether the singular point, if I take n is equal to infinity, 1 by infinity, 0. I want to know whether z is equal to 0 is isolated or non-isolated singular point. So I want to consider z is equal to 0. So you need to consider neighborhood of z is equal to 0. Neighborhood means up to what extent we need to consider neighborhood of z is equal to 0. Center of the circle should be z is equal to 0, and radius of the circle should be very nearer to 0 but not 0. Very nearer to 0 but not 0. Means radius of the circle is a delta. Delta value 0.001, minimum 2 zeros, maximum no limit 0.001, 0001, so on. Minimum 2 zeros compulsory. Now, look there. If I take n is equal to 1 here, I will get 1 is the singular point. If I take n is equal to 2 here, 1 by 2 singular point. Take n is equal to 3, I will get 1 by 3 singular point. Take n is equal to 1000. Take n is equal to 1 lakh. Take n is equal to 1 crore. So z is equal to 1 by 1 crore. 1 by 1 crore that is 0.701. 1 by 1 crore value 0.701. What is the radius of the circle you want to consider? I want to consider radius of the circle is 0.501. So this is 0, circle radius 0.501. But if I take n is equal to 1 crore here, it should be 1 by 1 crore, that is 0.701. 0.701 will lie inside the circle only. If I take n is equal to 10 crore, 1 by 10 crores. 1 by 10 crores means 1 by 10 crore value 0.801. 0.801. 1 by 1000 crores 0.1001. So all these values are lying inside the neighborhood of z is equal to 0. Neighborhood of z is equal to 0 means center at 0, radius 0.501. Not compulsory. If you want, you can take radius 0.1001. If you take radius 0.1001, then I will take n value 1 lakh crores. 1 by 1 lakh crores 0.1501. That obviously lies inside the neighborhood of z is equal to 0 only. So if z is equal to 0 is a singular point, some other singular points like 1 by 1 crore, 1 by 10 crores, 1 by 1000 crores, 1 by 10,000 crores, 0.601, 701, which are coming on to inside the circle. So therefore, if z is equal to z naught is a singular point of the function, one or more other singular points of the same function will lie inside the neighborhood of z is equal to 0. Therefore, z is equal to 0 is called a non-isolated singular point. A non-isolated singular point. Because some other singular points for large values of n coming into the circle, I mean inside the circle. So we are discussing about classification of singularities. Singular point means the point at which the given function cannot be analytic is called singular point. Further, this singular point is classified into different types. One is isolated singular point, one is a non-isolated singular point. Basically, all are singular points only. The next one is removable singular point. Removable singular point. Removable singular point means, I will explain with an example. Until then, you must have a patience. Suppose f of z is not defined at z is equal to z naught. F of z not defined at z is equal to z naught, but limit f of z as z tends to z naught exists finitely. Limit f of z as z tends to z naught exists finitely. Z naught is called removable singular point. Don't worry, I will explain with an example also. First to write, if f of z is undefined, if f of z is undefined, yet z is equal to z naught, and limit f of z as z tends to z naught exists, as z tends to z naught exists finitely. exists finitely, then z is equal to z naught is called a removable singular point. A removable singular point. And we can define like this also. Listen to me. Suppose you expand one given function as a Taylor series or Laurent series, whichever is possible. Your Laurent series expansion, your Laurent series expansion does not contain principal part. Does not contain principal part means does not contain negative powers of z minus z naught, then z is equal to z naught is also called a removable singular point. What I said, definition number 2, that is, if the Laurent series if the Laurent series expansion does not contain principal part. Principal part of the Laurent series means principal part of the Laurent series means negative powers of z minus z naught. Negative powers of z minus z naught is called principal part of the Laurent series. If the Laurent series does not contain negative powers of z minus z naught, that is, does not contain principal part, then z is equal to z naught is called a removable singular point. Next slide. A removable singular point. Don't worry, we see an example. Example, the example is applicable for the first definition as well as second definition. Both the definitions, let us cross check. For this example, that is f of z is equal to sin z by z. Let us verify the first definition right now. What is first definition? F of z is undefined at z naught. F of z is undefined at z naught, but limit f of z as z tends to z naught exists as a finite number. Okay. Let us see f of 0. F of 0 means sin 0 by 0. Sin 0 by 0 means 0 by 0 means sin 0 by 0 means undefined. And see, f of z is not defined at z is equal to z naught. Z naught means 0. But limit f of z as z tends to z naught exists finitely. But limit f of z as z tends to z naught. Z naught means 0 I took. Limit f of z as z tends to z naught exists finitely. So this is z tends to 0. F of z is sine z by z. No, you know sine theta by theta as theta tends to 0, 1. Even this is also 0 by 0. When you are solving the limit problems, whenever you get 0 by 0, apply L hospital rule. Sin z derivative cos z, z derivative 1. Cos, cos z by 1, z 0, cos 0, 1. Limit exists. Limit exists as a finite number. Limit exists finitely. Therefore, z is equal to 0 is a removable singular point. Now, let us verify the same example using the definition, using the second definition also. Using the second definition also, that is sin z by z or sin z by z 1 by z. We all know I have already given sin x expansion. Sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial multiply each and every term of the bracket function with 1 by z. 1 z cube by z, z square by 3 factorial, z power 5 by z, z power 4 by 5 factorial, z power 7 by z, z power 6 by 7 factorial. Now z can be written as, I want to write z as z minus 0. So its value will not change. Please write z as z minus 0 because its value will not change. Similarly, this is z minus 0 whole power 6 by 7 factorial plus 1. What is the definition? There are no negative powers of z minus z naught. If there are no negative powers of z minus z naught, no negative powers of z minus z naught, then z naught is called z naught is called a removable singular point. Z is equal to 0 is a removable singular point. Next definition, pole. Listen to me. Suppose there are finite number of terms in the principal part. Finite number of terms in the principal part means finite number of negative powers of z minus z naught in the Lorentz series expansion. Then z is equal to z naught is called a pole. This is also one type of singular point only. Redo. If there are finite number of terms in the Principal part means its meaning is finite number of. Its meaning is finite number of negative powers of. Finite number of negative powers of z minus z naught in the Laurent series expansion about z is equal to z naught, then z is equal to z naught is called a pole. Example, f of z is equal to e to the power of z minus 2 by z minus 2 whole cube. F of z is equal to e power z minus 2 by z minus 2 whole cube. This 1 by z minus 2 whole cube as it is. 1 by z minus 2 whole cube as it is into e to the power of x. I think you people know the formula for e to the power of x. That is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. Here e to the power of x means z minus 2. E to the power of x means z minus 2. E power x. Apply this formula. That is 1 plus x 1 plus x plus x square by 2 factorial plus x cube by 3 factorial plus so on. Multiply each and every term of the bracket function with 1 by z minus 2 whole cube. 1 by z minus 2 whole cube into 1 plus z minus 2 by z minus 2 whole cube, that is 1 by z minus 2 whole square, z minus 2 whole square by z minus 2 whole cube, 1 by z minus 2, z minus 2 whole cube by z minus 2 whole cube, still we have 1 by 3 factorial, so on. This is z minus z naught. Remember, suppose there are finite number of negative powers of z minus z naught. Suppose there are finite number of negative powers of z minus z naught. Z naught is called pole. Among all negative power of z minus z naught, which is the smallest negative power of z minus z naught? Smallest negative power of z minus z naught is minus 3. Here, z minus z naught power minus 3. Smallest negative power of z minus z naught is minus 3. Therefore, Z naught is called a pole. Therefore, Z naught is called a pole of order 3. Therefore, Z naught means 2 is called a pole. Is called a pole of order 3. Smallest negative power of Z minus Z naught is minus 3, which is called a pole of order 3. Pole of order 3, because smallest negative power of Z minus Z naught is minus 3. Next definition, essential essential singular point means, suppose the Lorentz series expansion containing infinite number of terms in the principal part. Infinite number of terms in the principal part means infinite number of negative powers of Z minus Z naught. Then Z naught is called essential singular point. Definition: if there are infinite number of negative, sorry, infinite number of negative powers of Z minus Z naught means what? Infinite number of terms in the principal part. Infinite number of terms in the principal part. If there are infinite number of negative powers of Z minus Z naught in the Lorentz series expansion of f of z about z is equal to z naught, then z is equal to z naught is called an essential singular point. We see an example. F of z is equal to sine of 1 by z minus 3. Consider this 1 by z minus 3 as x. Then it is sin x expansion. What is sin x expansion? X minus x cube by 3 factorial plus x power 5 by 5 factorial plus so on. Now this is 1 by z minus 3 as it is. This z minus 3 whole cube will come down to the denominator. Then it becomes 3 factorial into z minus 3 whole cube plus z minus 3 whole power 5 will come down to the denominator. That is 1 by 5 factorial into z minus 3 whole to the power of 5 plus so on. This is z minus z naught. So what I said, suppose there are infinite number of negative powers of z minus z naught. Z minus z naught power 1, power minus 3, power minus 5, power minus 7, minus 9, minus 11, so on. Therefore, z is equal to z naught means 3 is an essential singular point. And listen to me carefully. Every time, be careful what I'm saying. Every time series expansion may not be possible. In that case, how can you identify the nature of the singularity whenever the series expansion is not possible? So some other criteria must be adopted for classification of nature of singularities whenever the series expansion is not possible. That we see right now. Heading. Criteria for classification of nature of singularities. Remember, whenever the series expansion not possible, then in order to decide the nature of the singularity, please apply this procedure what I'm going to dictate right now. First case, consider f of z is equal to phi of z by psi of z. You are given f of z is equal to phi of z by psi of z. Denominator is equated to 0. Whatever the z values you get, those z values are called singular points. First, I want to equate the denominator to 0. That is, psi of z is equal to 0. We will get z values. And consider these z values as by denominator is equated to 0. We get some z values. Let it be z0, z1, z2, z3, so on. Denominator is equated to 0. Whatever the z values you get, those z values are called singular points. Substitute these singular points in the numerator. In case numerator not equal to 0, yet these singular points, then these singular points are called simple poles. Simple poles means pole of order 1. Because pole of order 1 means every number is repeated only one time. Suppose any number that is repeated more than one time, that we need to check in the second case. Suppose phi of z naught not equal to 0. Denominator is equated to 0. Whatever the z value you get, substitute that z value in the numerator. If a numerator not equal to 0 at this z value, then this z value is called a simple pole. Simple pole means pole of order 1. Don't worry, we see with an example. Whatever I have explained earlier, that let us verify with an example. I will choose f of z is equal to tan z. F of z is equal to tan z. Tan z can be written as sin z by cos z. And look there, numerator is phi of z. Numerator phi of z, denominator psi of z. So denominator is equated to 0. By equating denominator to 0, you will get z values. If you don't know, please remember this formula. Cos theta is equal to 0. Theta is equal to 2n plus 1 into pi by 2, where n belongs to integer. N is any integer. So cos theta is equal to 0. Therefore, theta is equal to 2n plus 1 into pi by 2, where n belongs to integers. Denominator is equated to 0. Whatever the z value you get, substitute that z value. Substitute that z value in the numerator. What I said, denominator is equated to 0. Whatever the z value you get, substitute that z value as it is in the numerator. Substitute that z value as it is in the numerator. Means phi of z, z value 2n plus 1 into pi by 2. That is sine of 2n plus 1 into pi by 2. All this 11th class or 12th class trigonometry only. 11th standard trigonometry only. All these values. Do you know this value? Sine of 2n plus 1 into pi by 2. Formula. Sine of 2n plus 1 into pi by 2 value minus 1 whole to the power of n, where n belongs to integers. Now this sine of 2n plus 1 into pi by 2 value minus 1 whole to the power of n, where n is integer. N is integer. Integer means 0. Minus 1 power 0 not equal to 0. Minus 1 power 1 minus 1 not equal to 0. Minus 1 power 2 1 not equal to 0. What I said? Denominator is equated to 0. You will get a z value. Substitute this z value as it is in the numerator. In case numerator not equal to 0, your substituted z value is called simple poles. Minus 1 whole power n for any integer value of n not equal to 0. Therefore, z is equal to 2n plus 1 into pi by 2, where n is integer, are called simple poles. Simple. Denominator is equated to 0. Substitute that z value in the numerator. If a numerator not equal to 0, your substituted z value is called simple pole. Criteria, second point. Consider f of z is equal to phi of z by z minus z naught whole power m. Next, put denominator should be equated to 0. Z minus z naught whole power m. Mr. Wait, if numerator becomes 0, we will be discussing. In each and every case, we discuss. Please wait. Denominator is equated to 0. We get z value. We get z is equal to z naught. We get z is equal to z naught. Z naught is repeated m times. Z naught, z naught, z naught. Like that it was repeated m times. Because z minus z naught whole power m was there. So z naught is repeated m times. Substitute this z value in the numerator. Suppose your numerator not equal to 0. Substitute this z value in the numerator. If in case numerator not equal to 0, then your substituted z is equal to z naught is called a pole of order m. Pole of order m. Because your z naught is repeated m times. That's why it is a pole of order m. Suppose z naught is repeated 2 times, pole of order 2. Z naught repeated 1 time, pole of order 1 means simple pole. e power 3z plus 10 by z minus 3 whole power 7 plus 9z. Denominator is equated to 0. You will get z value and assume this is phi of z and this is z minus z naught whole to the power of m. Denominator is equated to 0. We got z is equal to 3. Z minus 3 whole power 7 is equal to 0. So z is equal to 3. Substitute this z is equal to 3 as it is in the numerator. Phi of 3. Phi of 3 means z should be replaced by 3. Phi of 3 is equal to e power 3 into 3 plus 9 into 3. E power 3 into 3 plus 9 into 3. Whatever this is e to the power of 9 plus 27. Whatever it may be, answer not equal to 0. Answer not equal to 0. Denominator is equated to 0. Whatever you get, substitute the z value in the numerator. If numerator not equal to 0, then your substituted z value is called a pole. But this z is equal to 3 is repeated 7 times. So it is a pole of order 7. Now case 3. Because numerator becomes 0, what to do now? We will discuss in case 3. Consider f of z is equal to phi of z by z minus z naught whole to the power of m. A denominator is equated to 0. We get z value as z naught and it was repeated m times. Substitute this z value in the numerator. In case numerator is not equal to 0, z is equal to z naught is a pole of order m. In case numerator becomes 0, we are discussing numerator becomes 0, then find the, everyone must be very careful regarding this step. Then find the, otherwise you cannot understand. Then find the order of 0 of z naught for the function phi of z. Whenever numerator becomes 0, be careful what I am saying. Whenever numerator becomes 0, then find the order of 0 of z naught for the function phi of z. You should not get confused. Let me explain. Numerator becomes 0. Then immediately differentiate the numerator. Means find phi dash. Find phi dash. I mean phi dash of z naught. Suppose phi dash of z naught is equal to 0. Find phi dash. Suppose phi dash of z naught is equal to 0. Then immediately phi dash of z naught not equal to 0. Z is equal to Z naught is a 0 of order 1. Suppose phi dash of Z naught 0, then find phi double dash of Z naught. Suppose phi dash of Z naught 0, phi double dash of Z naught not equal to 0, Z naught is a 0 of order 2. Suppose phi dash of Z naught 0, phi double dash of Z naught 0, phi triple dash of Z naught not equal to 0, Z naught is a 0 of order 3. Suppose phi dash of Z naught 0, phi double dash of Z naught 0, phi triple dash of Z naught 0, fourth derivative of phi of Z naught not 0, Z naught is a 0 of order 4. This is the way we need to find phi dash, phi double dash, phi triple dash, so on, until its a derivative order should not be 0. Until then you need to find. Here, first case, if Z is equal to Z naught is a 0 of order n. Sorry, not first case. If Z is equal to Z naught is a 0 of order n such that, remember, Z is equal to Z naught is a 0 of order n means first time derivative of phi of Z 0, second time derivative of phi of Z 0, third time derivative of phi of Z 0, n minus 1th time derivative of phi of Z 0, n minus 1th time derivative of phi of Z, nth time derivative of phi of Z not equal to 0. Then only Z is equal to Z naught is a 0 of order n. Then Z is equal to Z naught is called 0 of order n such that m greater than n. Don't get confused. What is m? Look here, this is m. M means this. Z minus Z naught power m. This m. Such that m greater than n. Then Z is equal to Z naught is a pole of order m minus n. Suppose m value is equal to n or m value less than n, m is equal to n or m value less than n, then Z is equal to Z naught is called a removable singular point. Don't worry what I have explained in first point and second point. I will explain with an example. With an example. Example 1, f of z is equal to one minus e to the power of 2z by z power 4. So I will write like this, f of z is equal to 1 minus e power 2z by z power 4. Denominator z power 4 is written as z minus 0 whole to the power of 4. The numerator function let it be phi of z, and the denominator is z minus z naught whole to the power of m. Denominator is equated to 0. Z power 4 is equal to 0. Denominator is equated to 0. Z power 4 is equal to 0. So Z is equal to 4. Sorry, Z is equal to 0. Substitute Z is equal to 0 in the numerator. Substitute Z is equal to 0 in the numerator. Numerator is phi of Z. Take Z is equal to 0. Phi of 0 is equal to 1 minus e power 0. E power 0 is 1. 1 minus 1, 0. Whenever numerator becomes 0 at z naught, immediately find phi dash, phi double dash, phi triple dash. You can find in this manner until numerator not equal to 0. Until numerator not equal to 0, find phi dash, phi double dash, so on. 1 derivative 0 minus e power 2z derivative 2 e power 2z. Take z is equal to 0. Phi dash of 0 is equal to minus 2 into e power 0. That is minus 2 not equal to 0. Minus 2 not equal to 0. Denominator is equated to 0. We got z value. Put in the numerator. Numerator becomes 0. Find phi dash. Phi dash 0. So first derivative 0, first numerator, first derivative not equal to 0. First derivative of numerator not equal to 0, then z naught is called 0 of order 1. First derivative of numerator 0, but second derivative of numerator not equal to 0, z naught is a 0 of order 2. First derivative of numerator not equal to 0 at z naught. So z is equal to z naught means 0 is a, z is equal to z naught is a 0 of order 1. 0 of order 1. Remember, order of 0 denoted by n. N. Order of 0 denoted by n. First derivative of numerator not equal to 0. So z naught is a 0 of order 1. 1 means n is equal to 1. Look there. M value 4, n value 1. M value 4, n value 1. M greater than n, pole of order m minus n. M is equal to n, m less than n, removable singular point. M greater than n here. Therefore, z is equal to z naught is a pole of order m minus n. M minus n means 4 m minus n, 4 minus 1. Example number 2. F of z is equal to z minus sin z by z cube. F of z is equal to z minus sin z by denominator z cube is written as z minus 0 whole cube. What is the general form? Phi of z by z minus z naught whole to the power of m. You have to wait for 5 to 10 minutes maximum so that this topic will be completed. Tomorrow we will complete the syllabus. Denominator is equated to 0. I got z value. Substitute this z value as it is in the numerator. Denominator is equated to 0. We got z value. Put that z value in the numerator. That is phi of 0. That is 0 minus sine 0. If numerator becomes 0, then find phi dash, phi double dash, phi triple dash, so on until its a derivative value not equal to 0. Phi of z is z minus sine z. Phi dash of z is 1 minus cos z. 1 minus cos z. Take z is equal to 0. Phi dash of 0 is equal to 1 minus cos 0. Cos 0, 1, 1 minus 1, 0. If first derivative 0, no issue. Go for second derivative as well. 1 derivative 0. Cos z derivative minus sin z. Minus into minus plus sin z. Second derivative also 0. Phi double dash of z naught. Phi double dash of z naught means phi double dash of 0 sin 0 0. Second derivative 0, no issue. Go for third derivative. Third derivative 0, go for fourth derivative. You have to find again and again and again until your derivative order should not be 0. Phi triple dash of z, that is cos z. Take z is equal to 0. Phi triple dash of 0 is equal to cos 0, that is 1. 1 is not equal to 0. Third derivative of phi of z. Third derivative of phi of z not equal to 0. So phi of z, sorry, if third derivative of phi of z not equal to 0, then z is equal to z naught. Then z is equal to z naught means 0. Then z is equal to z naught is a 0 of order 3. 0 of order 3. Remember, order of 0 is denoted by the symbol. Order of 0 is denoted by the symbol n. Order of 0 denoted by the symbol m. N for New Delhi. Here m value 3. Here m value 3. Here n value 3. M value 3, n value 3. M greater than n, whole of order m minus n. M is equal to n, m less than n. Both the cases z is equal to 0 is a removable singular point. In the same manner, note this and try yourself. F of z is equal to sin z by z cube. Given in the GATE Instrumentation Engineering 2010. Next. F of z is equal to 1 minus e power minus z by z. Next, f of z is equal to sin z minus 2 by z minus 2. F of z is equal to 1 minus cos z by z. F of z is equal to 1 minus cos z by z square. See, all these answers, all these problems answers, removable singular point. Z is equal to, all these answers removable singular point. Even the previous one also, z is equal to 0. This is also previous one also removable singular point only. Just 2 minutes. It is completed. One more topic. It will take 5 minutes. Will you have the patience for 5 more minutes? Just 5 minutes. Please wait. One more definition. Only 5 minutes. Criteria, next point. Write down. Last one, only 5 minutes. If there are, okay, we'll do one thing. This fourth point we will discuss tomorrow. No issue. Syllabus will be completed. You'll see tomorrow fourth point. Let us stop the class for today. Fourth point we see tomorrow. We are able to complete the syllabus tomorrow. And let me take the doubts, and if you have any, one by one in the sequential order only.
Hello, sir.
Shahil.
Yes, sir. Good evening, sir.
Tell me, Shahil.
Sir, I had doubt in the 7th question in which z minus 1, z minus 2 is valid for mod of z less than 1 and mod of z less than 2.
Slide number, do you remember?
No, sir, I didn't write note down the slide, sir.
At least tell me the
classification of singularity, 2 pages before classification.
Okay. Classification of singularities.
Yeah, this question, sir.
1 minute. Classification of singularity. This one?
No, sir. More back. 2
this
pages
one?
more. 2 pages more back, sir.
This one?
No, sir. Back. Previous. 150 around.
This is 150 is Lorentz series. From 150 onwards, classification of singularity.
Yes, sir. Before in Lorentz series, I have doubt.
Doubt in Lorentz series, Problem number?
Yes, sir. This equation. This one. Sir, my doubt was, how did we know that the first case we took mod of z less than 1, and then we assume
1 minute. Where mod of z less than 1, where we were given this one, or you are talking about this? I think you are. Yeah. This one, I think you are talking, right?
Yes, sir.
In the statement of the problem, you are given, no? Look, you are asked to expand 1 by z minus 1 into z minus 2 valid in the region. First problem, mod z less than 1.
Yes, sir.
So first problem, mod z less than 1, and second problem, mod z greater than 2. Second problem, mod z greater than 2.
Yes, sir. My problem is, how did we know that mod of z would be less than 2? Where we have written now.
Listen to me. Listen. Mod z less than 1 given, no?
Yes, sir.
Mod z less than 1. Mod z value less than 1. 1 should be less than 2, no?
Yes, sir.
Mod z value less than 1 you are given, and we know that 1 is less than 2. Correct or not?
Yes, sir.
So why I have taken 1 less than 2? Because another function is z minus 2 here. That's why 1 less than 2 I have taken. Suppose another function is z minus 3 here, I would have taken 1 less than 3.
Okay, sir.
Is it clear, Sahil?
Yes, sir. Yes, sir. And so one more doubt, sir. Sir, in this question, like we are doing, we just took that 1 less than 1, and then we took the 2 in the denominator, and just a couple of questions back before, we were using for Lorentz series z equal to 1, and in that we were substituting.
Somebody is speaking. Please,
Nadeem,
unmute
could you please unmute yourself?
Not
Nadeem.
getting Mr. Sahil. Somebody is talking.
Yes, sir.
Hello, I'm not talking.
Tell me.
I'm not talking.
No, not you. Somebody inside the home.
Yes, sir. My doubt was that right now in Lorentz series, which we are using this mod of z less than 1. And just a couple of questions before, we were using for Lorentz series z equal to 1, and then we were replacing it with a t, and then we were solving it.
Yes. In the previous problem, we were not asked to expand the function. Previous problems are we were asked to expand the function at some particular point. But in this problem, we were asked to expand in certain region. Suppose you were asked to expand the function at some particular point. That particular point will be taken to the left side and it should be assumed as t. But here we were asked to expand in certain region.
So for that, we will use separate form to
Concept
procedure.
different. Look. Here we were asked to expand at the point z is equal to -2.
Yes,
2
sir.
goes to left side. Z plus 2. Assume z plus 2 is equal to 2. Here point is given, but here region is given. If point is given, do like that. Region is given, do like this.
Okay, sir. Fine. Thank you very much.
Next. In the next, please mute yourself, Mr. Sri Charan.
Hello, sir.
Sri Charan, tell me.
Sir, same 148 page number, sir.
148. Tell me.
Sir, if z less than 1, and if it will not contain 1, no, sir.
Pardon? If z less than 1?
It will not contain 1, no, sir.
Listen to me. Z less than 1 means it is a circle with center at 0, 0, radius 1. Z less than 1 means area inside the circle, not on the circle.
Okay.
Not containing 1. See, listen to me. You are not containing 1. Taylor series is valid only when function analytic inside the circle. Means f of z is a finite number at any point inside the circle, Taylor series. Suppose f of z is infinite at any point inside the circle, Lorentz series possible. If you take z is equal to 1 in the given function becomes infinity, no?
Yes, sir.
So, substitute your singular point in the function. Answer finite number, Taylor series possible. Answer infinite number, Lorentz series possible. Sri Charan,
sir.
What's the doubt? Sri Charan.
Actually, I thought that if z less than 1, it not contains 1. If z less than 2, it contains 1, no, sir. I thought like that.
1 minute, please be on the line. Did you remember the Lorentz series graph?
Yes, sir.
Okay, look here, z less than 1 less than z less than 1 less than 2 means, look there, z less than 2 means this is z is equal to 2, right? Z less than 1 means this is z is equal to 1, right? Z less than 2 means this, but it will not be considered because inside the circle at this point only function will not be analytic. 1 minute, Lorentz series is there. 1 minute, please be on the line. This inner circle is, see, inner circle is z less than 1. Area inside the small circle is z less than 1. Sri Charan?
Sure, okay.
See, z less than 2 means area inside the circle. Z less than 1 means area inside the small circle. Area inside the small circle will not be considered.
Okay. Yes, sir.
Doubt is what? Sir, z less than 2, it is including 1 also, correct?
Sir.
Actually, listen, total area inside the circle z is equal to 2 except z is equal to 1. Then only Lorentz series possible. Total area inside the circle z is equal to 2 except at z is equal to 1. Its meaning.
Okay, sir.
If z is equal to 1 is there, it is not defined at z is equal to 1. If it area inside the circle 2 except at 1, that 1 is a smaller circle. Otherwise, how it is possible?
Okay.
Is it clear?
Yes, sir. Clear.
Then only Lorentz series possible. All Rn series expansions like that only. Inside the bigger circle, another total area inside that, and inside that one more point. At that point, function will not be defined.
Yes, sir, I got it.
Next. That's it. Next, Manideep. Please
Hello,
tell me. Manideep.
124. 24.
This is 124. Manideep, this
Yes,
one?
sir.
Huh?
Previous page, sir.
This one, huh?
पापा चुप हो जाइए
125. 125, sir.
This one, huh?
125. Sir, in this, how would you take d differential of 14 by d by dx? It's 50. It's 450.
I didn't get how I took which step.
This steps f of f power 14 I by 14 factorial.
This first step, okay na? This first step.
Okay, sir. Okay.
Second step, okay na?
Second step 14 factorial. This is differentiation.
You want second step, okay?
No.
Listen to me. 1 time derivative of z is 1 factorial. 2 times derivative of z square is 2 factorial. 3 times derivative of z cube is 3 factorial. 14 times derivative of z power 14 is 14 factorial. So 14 times derivative of z power 14 is 14 factorial. This is okay na?
Okay, sir.
Next, we want 14 times the differentiation of z power 15, no?
15.
Remember 1 time derivative of z square. Look here. Here I have written 1 time derivative of z square is 2 factorial into z. 2 times derivative of z cube is 3 factorial into z. 3 times derivative of z power 4 is 4 factorial into z. 4 times derivative of z power 5 is 5 factorial into z. Here z square 2 factorial z. Z cube 3 factorial z. Z power 4 4 factorial z. Z power 15 15 factorial z. Here 1 time derivative of z square, 2 times derivative of z square, z cube, 3 times derivative of z power 4, 14 times derivative of z power 15. 1, 2, 2, 3, 3, 4, 4, 5, 14, 15. Is it clear?
Okay, sir.
Now you understand?
Understand, sir.
Any doubt? Still you are getting doubt.
No, sir.
Got it?
Last to second step, we common the 14 factorial.
Yes, yes. Now this 15 factorial I have written as 15 factorial can be written as 15 into 14 factorial. Now
Okay, sir.
3 factorial can be written as 3 into 2 factorial. 15 factorial can be written as 15 into 14 factorial. So here 14 factorial common. Take it out. 14 factorial into 1 plus 15z. Now take z is equal to y. Is it clear?
Yes, sir. Clear. Sir, 136 page number.
Page number?
136.
Tell me. This is 136.
Sir, in this, sir, in this z minus pi whole square coefficient of means why did you take f double by pi by 2 factorial?
Why I take? Actually, remember in the definition, but you need to remember because I can't say all those things. Look here, z minus z naught whole square coefficient how much? Z minus z naught whole square coefficient how much? F double dash of z naught by 2 factorial, correct?
Hi, sir.
Take z naught is equal to pi, take z naught is equal to pi, z minus pi whole square into f double dash of pi by 2 factorial. So z minus pi whole square coefficient is f double dash of pi by 2 factorial.
Okay, sir. Okay.
Got it? So
Hi, sir.
z minus pi whole square coefficient is f double dash of pi by 2 factorial from the definition.
Okay, sir.
Is it clear or still doubt?
Sir, 139. Clear, sir. 139.
Next.
139.
This is on 39.
Sir, in this e power 2t means you wrote a whole this. Oh, sir.
See, z minus e power 2t means, pardon?
That one only, sir.
I didn't get what you are asking.
E power 2t.
How it comes up?
Sir.
Look there. Did you remember this assumption? Z minus 1 is equal to t na?
Hi, sir.
Then z is equal to how much?
Z equal to t plus 1.
Z is equal to t plus 1. I want e power 2z. That's why first I will find 2z. Multiply both sides by 2. 2z is equal to 2t plus 2. Now e power 2z is equal to e power 2t plus 2. E power 2z is equal to e power 2t into e power 2. Bases same, powers
Yes,
will be
sir.
added. Is it clear?
Yes, sir.
That's it.
You wrote e power t equal to 1 plus 2
That
into
is-
this, sir.
You are not at all.
No.
You are not at all remembering anything.
Okay, okay, sir.
Before that introduction, please remember why I gave the formula. Look
E
there.
power is equal to formula.
Look there. E power x. In place of x,
Yes,
take
sir.
2t. E power 2t, no? 1 plus
Okay,
2t
okay.
plus 2t square by 2 factorial plus 2t cube by 3 factorial plus 1. Formula.
Okay, sir.
Got it?
Got it, sir. Thank you.
Next. Madhi Srikiran. Please unmute yourself and then talk.
Hello, sir.
Next, Namrata.
Hello, sir.
Tell me, Srikiran.
Sir, Lawrence series third sum, sir.
Lawrence series third problem. Okay. This one,
Yes, sir. Sir,
tell me.
in the expansion, it doesn't contain z minus z naught negative powers, no, sir.
See, listen to me, Srikiran. Your name is Srikiran?
Yes, sir.
Listen to me. Any series expansion contains only negative powers or positive powers as well as negative powers. That is Lorentz series. Only positive powers is Taylor series. Only negative powers or positive powers as well as negative powers is a Lorentz series. Now you ask.
Sir, in this expansion, sir.
In this expansion, doubt
No,
it.
there is no. Okay, sir. There is negative powers.
Negative power z minus 1 whole power minus 3
Yes,
whole
sir.
power minus 2 whole power
Again.
minus 1. Negative powers 11 ko. It is a Taylor series.
ఓకే సార్ అంటే ఇప్పుడు నెగిటివ్ పవర్స్ లేకుంటే లారెన్స్ సిరీస్ అడిగినా
కానీ టేలర్ సిరీస్ రాయాలి.
ఓకే సార్ అంటే సబ్సెటా సార్ అదే లారెన్స్ సిరీస్ లో టైలర్ సిరీస్ అనే సబ్సెటా?
అవును
సార్ ఇంకో డౌట్ సార్ పేజ్ నెంబర్ 148 సార్ ఇది కాదు సరే జెడ్ ఈక్వల్ టు పాయింట్ ఇచ్చారు కదా సార్ జెడ్ ఈక్వల్ టు 2 అని ఒక సమ్
అదే దీనికి ముందు అనుకుంటాను.
ఈ పవర్ ఎక్స్ ఎక్స్పాన్షన్ ఉంటుంది దాంట్లో
ఇదేనా?
ఎస్ సార్ ఈ సమ్లో మనం అంటే అక్కడ ఎక్స్పాన్షన్ పాయింట్ ఇచ్చారు కదా సార్
అవును.
పాయింట్ అక్కడ పాయింట్ ఇచ్చినప్పుడు ఈ పవర్ ఎక్స్పాన్షన్ అనేది మాత్రం దాని ఆర్ఓసి అంటే దాని స్టాండర్డ్ ఫార్మ్ జెడ్ మోడ్ జెడ్ లెస్ దాన్ ఇన్ఫినిటీ ఉంటుంది కదా సార్ దాని ఆర్ఓసి.
అవును.
అంటే ఇక్కడ పాయింట్ ఇచ్చారు కదా అక్కడ ఏమో రీజియన్ ఆఫ్ ఆర్ఓసి ఉంది కదా సార్ స్టాండర్డ్ ఫామ్ లో.
దట్ సిరీస్ ఈ బ్రాకెట్ లో రాశాను కదా, ద సిరీస్ దట్ ఐ హావ్ రిటర్న్ ఇన్సైడ్ దిస్ బ్రాకెట్ హియర్ this is valid 1 plus 2t plus 2t square by 2 factorial. This series is valid in the infinite region.
Okay,
Only e power 2z valid in the region infinite region. But 1 by z minus 1 is also there, no? It is product of two functions. A new function ostundi, you will get a new function. Only e power 2z is there, region z less than infinity. But product of two functions, e power 2z into 1 by z minus 1 whole cube. That is a new different function.
ఓకే సార్. సార్ ఆ లారెన్స్ సిరీస్ అనేది రెండు సర్కిల్స్ లో కామన్ ఏరియాకి అప్లై అయింది సార్ అది.
Lorentz series listen to me, area occupying between two circles, any function which is analytic between two concentric circles, then only Lorentz series is applicable. Sometimes outer circle may be at infinite distance and inner circle may be a zero circle also, and completely outside the region.
ఓకే సార్.
Is it clear?
Yes sir, done.
That's it.
Yes sir, that's it. Thank you.
Next, Namrata, followed by please.
Good evening.
Good evening, Namrata. Tell me. Next, Sai Krishna.
Yes. Good evening, sir. I have doubt in this removable singular points. All I could get from the last question is that if m minus n is equal to 0, then we can call it as removable singular points. What is the exact definition of it, sir? Like, I could not get even the example of it.
I didn't get what you are asking. This which one? This.
So if you could, sir, define removable singular point one more time, then it will be
if you want, you
helpful.
can find according to the definition I gave. Look, suppose this in this example, if I take z is equal to 0, right? In the second example.
Yes, sir.
Then it is f
Yes,
of
sir.
0 is equal to 0 by 0, na?
Yes, sir.
Then f of 0 is undefined. Na?
Yes, sir.
0 by 0 means undefined. So
Undefined. Yes, sir.
removable singular point means f of z not undefined, but limit f of z as z tends to z not exists finitely. So find the limit f of z as z tends to 0, and you will get 0 by 0 form. Apply L'Hospital rule. You will get the answer then.
Oh, okay, sir.
Is it clear, Amma?
Yes, sir. Yes.
Any other?
And sir, I would like to say that you teach really, really well, sir. Thank you so much.
Thank you. That's it. Next.
Hello, sir. Good evening.
Next to go Sai Krishna, na?
Yes, sir. Yes, sir.
Tell me, Sai Krishna.
Sir, the 154F page loans.
154F. Tell me.
Sir, ఇక్కడ z equals to 1 by n కండిషన్ లో n not equals to 0 అని ఇచ్చారు, అది కొంచెం డౌట్ గా ఉంది సార్.
1 by n అంటే n దగ్గర 0 తీసుకున్నాం అనుకో, 1 by 0 ఎంత?
ఇన్ఫైనైట్ అవుతుంది సార్.
అంటే అన్డిఫైన్డ్ కదా, ఇన్ఫినిటీ అనే నంబర్ అన్డిఫైన్డ్, అంటే 1 by n is undefined at n is equal to 0 కదా.
అవును సార్, కానీ అప్పుడు tan pi by z కదా సార్, z ఇన్ఫినిటీ కాబట్టి tan 0 అవుతుంది, కానీ tan 0 డిఫైన్ అవుతుంది కదా సార్, అంటే tan 0 అంటే 0 అవుతుంది కదా.
ఇక్కడ z is equal to 0 తీసుకుంటే tan ఇన్ఫినిటీ అవుతుంది కదా.
z equals to అంటే n equals to 0 తీసుకోకూడదు కదా సార్, n equals to 0 తీసుకుంటే z ఇన్ఫినిటీ, అప్పుడు tan pi by z అంటే pi by ఇన్ఫినిటీ అంటే tan 0 అంటే
సింగులర్ పాయింట్ pi by z ఎందుకు మాట్లాడుతున్నావు నువ్వు? సింగులర్ పాయింట్ z కే మాట్లాడాలి. డినామినేటర్ ని by equating the denominator to 0, whatever the z values you get, those z values are called singular points. Here pi by z, why you are talking about? You should find z only. Whatever the z you get, that is called singular point.
అంటే ఓకే,
pi by z గా తీసుకుంటున్నావు. pi by z undefined at n is equal to 0. pi by z defined at n is equal to 0.
సో అంటే z డిఫైన్
pi by z అంటే ఇక్కడ చూడమ్మా, బిఫోర్ స్టెప్ లో 1 by z డిఫైన్డ్ at n is equal to 0. కరెక్టా కదా?
అవును సార్. yes sir.
Z undefined. Singular point should be in terms of Z, not should be in terms of 1 by Z, not should be in terms of pi by Z.
ఓకే సార్. ఇంకోటి సార్, లాస్ట్ లో కొన్ని క్వశ్చన్స్ ఇచ్చారు కదా సార్,
అన్ని రిమూవబులే.
అందులోని అంటే ఇప్పుడు మామూలుగా లిమిట్ మీరు ముందు రిమూవబుల్ డెఫినేషన్ ఇచ్చినప్పుడు
డెఫినేషన్ ప్రకారం కూడా చేయొచ్చు, వ్యాలిడ్ అవుతుంది.
అంటే సార్ ఇలాంటి క్వశ్చన్స్ ఇచ్చినప్పుడు ఫస్ట్ రిమూవబుల్ చూసుకో ఎలా ప్రొసీడ్ అవ్వాలి సార్? అంటే
నేను ఇంకా అయిపోవాలి, కంప్లీట్ అయిపోతే క్లారిటీ వస్తుంది. ఇంకా దీని ఎక్స్టెన్షన్ రేపు చెప్తాను. ఏంటంటే ఫస్ట్ సిరీస్ ఎక్స్పాన్షన్ పాసిబుల్ అయితే గివ్ ద ఫస్ట్ ప్రయారిటీ ఫర్ రైటింగ్ ద సిరీస్ ఎక్స్పాన్షన్ and decide the nature of the singularity. Whenever series expansion not possible, then only you need to identify the criteria. ఇప్పుడు ఈ ఫోర్త్ ప్రాబ్లం e power minus z సిరీస్ ఎక్స్పాన్షన్ ఉంది కదా,
అవును సార్,
అన్నిటికీ సిరీస్ ఎక్స్పాన్షన్ ఉంది. గివ్ ద ఫస్ట్ ప్రయారిటీ ఫర్ రైటింగ్ ద సిరీస్ ఎక్స్పాన్షన్ ఇన్ ఆర్డర్ టు డిసైడ్ ద నేచర్ ఆఫ్ ద సింగులారిటీ. whenever series expansion not possible, then only you have to use the criteria what we are discussing in the last session of the class.
Okay, sir. Okay. Thank you very much, sir.
Thank you. Next, in the sequential order, Srikar.
Hello, sir.
Tell me, Srikar.
Sir,
Sir,
in the problem you gave last, question number 3, sir, f of z equal to sin z by z cube.
Fine.
Sir, it is not a removable singularity, no, sir, because
sorry, it is a pole of order 2. Correct, it is a pole of order 2 by mistake. Pole of order 2.
Okay, sir, that was sir,
sorry, by mistake I said it is a pole of order 2. The remaining are removable.
Sir, and the homework problem which you gave before, classification of singularity, sir. Sir, once you can open that, sir. Sir, this one. Sir, here I have used z plus 2 equal to t, sir. Sir, so
that is 1 minute. That is 100% correct. But before that, degree of numerator is less than degree of denominator. Split into partial fractions and then go ahead.
Sir, my doubt is, sir, I have got a in terms of t as t minus 2 by t minus 1 into t, sir.
1 minute. Tell me t
minus 2 by t minus 1 into t.
Fine, that is.
Sir, I divided into partial fractions also.
A by t plus b by t minus 1.
Sir, a is 2
equal to 1 minute. A is equal to
2, sir.
2 by minus 1, 2, right?
Yes, sir.
B is equal to 1 minus 2 minus 1. Then A value 2 by t, B value minus 1 by t minus 1.
Sir, here I
2 by t. T means what? Z plus 2. We already got the first term. See.
Yes, sir.
This here I will put plus symbol, minus symbol I will take down. 1 minus t it will become. Then
yes,
2 by t plus 1 minus t whole power minus 1 expansion. Please check there. Same thing.
Sir, here only my doubt is, sir, modulus of t should be less than 1, no, sir, to apply that binomial expansion.
Yes, mod t less than 1. I agree with you.
Sir, but how can we prove that mod t is less than 1 here, sir? Sir, in the previous they have given a condition so that we found that some mod z is less than 1, but how to check mod t whether less than 1? That's why my doubt, sir.
1 minute.
I got the answer, but that is the doubt.
1 minute. I will show you right now. Wait for 1 minute. Tell me the expansion of 1 minus x whole power minus 1.
Sir, 1 plus x square plus x cube, so on up to infinite terms.
What is the is it in geometric progression?
Yes, sir.
Sum of infinite number of terms of geometric progression is?
Okay, sir. A by 1 minus r when r is less than 1, sir.
Okay, na?
Okay, sir. I understood, sir. Then t must be mod t must be less than 1, sir, to get in that form.
Is it clear?
Okay, sir. Thank you, sir.
Okay.
Oh, sir. It's a very good understanding of math, sir. Thank you, sir.
Thank you.
Okay, sir.
Next, Harika.
Hello, sir.
Tell me, Amma. Next, Akansha. Harika.
Sir, page number 147.
Tell me.
Sir, here we are Mod less than 1 we are taking according to pole, sir.
No,
1 less than 2.
look. Here you are given mod z less than 1. Correct?
Yes, sir.
But two functions are there. So we need two regions. But you are given mod z less than 1. But why I wrote 1 less than 2 is another pole is z2. That's why 1 less than 2. Suppose another pole is 3, I mean z minus 3 here, you need to write 1 less than 3.
If poles are negative, sir.
Poles are?
Negative. Z plus 3.
If poles may be negative, then 1 less than minus 3.
1 less than. Okay, sir.
Correct or not?
Yes, sir.
That's it, Amma.
Sir, problems on radius of convergence.
You want radius of convergence, huh?
How to find, sir?
Radius of convergence means the distance between center of the circle to the nearest singular point. For example, which one? I will explain one problem regarding radius of convergence. See, the distance between center of the circle to the nearest singular point is called radius of convergence. For example, radius of convergence is r is equal to singular point distance between center of the circle and the nearest singular point. Center of the circle, my nearest singular point. What is the center of the circle? You are asked to expand. See here, you are asked
Center
to
0.
Center 0
Zero.
na.
Z minus Z naught.
1 no?
Sir, 1.
Center of the circle is 1. What is the radius of the distance between center of the circle and the nearest singular point? So for this function, what is the singular point? 1 only.
Yes, sir.
E power 2z by z minus 1 whole cube. What is 1 singular point? So center of the circle 1 minus singular point also 1. 1 minus 1 0. What is the radius of convergence?
0.
0. Radius of convergence means modulus of difference between center of the circle and the nearest singular point.
Okay,
Why
sir.
I said nearest singular point is sometimes two singular points are there. Here 1 and 2.
Yes, sir.
Here what are the singular points? 1 and 2.
1 and 2.
Which singular point is nearer to the center of the circle? That will be taken as a singular point.
Okay, sir.
So modulus of difference between circle center and the nearest singular
Nearest
point
point.
is called radius of convergence.
Yes, sir.
Okay, Nama?
Okay, thank you, sir.
Region of convergence means modulus of z minus z naught less than r. Z naught is the center, r is the radius of convergence.
Okay, sir.
Okay.
Hello, sir.
Next sequential. Next Akansha, tell me, Amma.
Hello.
Akansha.
Yes, sir. Sir, you explained that topic criteria for classification of the nature of singularity.
Tell me.
Follow up that means what do you want to say? Can you, in short, explain what is its significance?
Actually, basically, the point at which function undefined, the point at which function is not analytic is called singular point. Correct, no?
Yes, sir.
The point at which function not analytic is called singular point. Suppose there are no other singular points around some region of that singular point, your singular point is called isolated. No particular practical significance whenever you go inside in depth of mathematics, we are particularly classifying. It is a singular point. There are no other singular points very, very nearer to that singular point that is isolated. There are some other singular points which are nearer to original singular point that is non-isolated. And singular points different types. Basically, all are singular points only.
Yes, sir.
Significance means practically it doesn't have any significance. So it is pure mathematics insight only. It is basically singular point. We are classifying the singular point nature, how it is behaving.
So page number 167.
160.
167.
Tell me.
Sir, means in this question you were telling about that pole 0, I got disconnected at that time. Can you please in short explain?
Which one should I explain in this?
So criteria 2, second point.
Up to this z is equal to z naught is a 0 of order n. Up to that is okay?
So one page behind.
That's why I'm asking. Because you are asking in the middle. Denominator is equated to 0. You will get z value. Substitute that z value in the numerator. In case numerator not equal to 0, your substituted z value is a pole. In case numerator 0, like phi of z naught 0. Are you getting?
Yes, sir.
If numerator 0, then find the order of z naught for the function phi of z. Find the order of z naught for the function phi of z means find phi dash, phi double dash, phi triple dash, so on. Why
Which
we
we
have
have done in the question.
find phi dash, phi triple dash, phi double dash, phi triple dash, so on until your derivative order not equal to 0. Is it clear?
Okay, yes, sir, yes, sir.
Suppose.
Sir, and point number 2, yes, sir.
Slide number?
Point number 2.
Suppose z is equal to z naught is a 0 of order n. 0 of order n means phi dash 0, phi double dash 0, phi triple dash 0, so on phi power n minus 1 of z naught 0, but phi power n of z naught not equal to 0. Nth derivative not equal to 0. So then z is equal to z naught is a 0 of order n. And here this is m. Look here. This is m. Okay na? Suppose m greater than n. M greater than n. Z naught is a pole of order m minus n. Suppose m is equal to n. M less than n. Z naught is a removable singular point. M less than n or m is equal to n.
Yes, sir, yes, sir, this I understood. Sir, point number 2, please.
Point number 2. M is equal to n.
No,
M
sir, not this. That in that page number 164, I guess.
This one,
165?
This one,
Yes, sir, yes, sir.
Denominator is equated to 0. You got z is equal to 3.
Yes,
Substitute z is equal to 3 in the numerator. Numerator not equal to 0. So z is equal to 3 is a pole. Pole of order 7 because this number is repeated 7 times. That's why it is a pole of order 7.
Okay, it's the same thing.
Same story.
Okay, sir. Sir, I was solving some previous year question.
If you have any doubts, you can WhatsApp to me. I'll clarify because other students are also raising hands. Still, you have any doubts, ask me fastly.
Okay, sir. I will WhatsApp.
You can mail me or you can WhatsApp. I'll send the answers if you have any queries.
Sir, just that e to the power z is periodic with period. What will be its period? E to the power z.
Period means f of x plus t is equal to f of x. That is a periodic function. It is very simple. You just WhatsApp me. I'll send the answer. Very simple. The answer I will send. You can understand easily. Or tomorrow I'll clarify. Okay, na?
Okay.
It will take only 5 minutes. Okay, na? Other student is waiting. Na?
Okay.
Next, Varsha.
Hello, sir.
Tell me, Amma.
Sir, 125F, sir.
125.
Sir, in that last step, I can understand, sir. That 14 factorial plus 15 into 14 factorial into set that. Can you please explain?
This one, Amma, second step.
Sir,
This one, na?
Yes, sir.
Look, 14 times derivative of 1, 0, na?
Yes, sir.
14 times derivative of z0, 14 times derivative of z square 0, 14 times derivative of z power 13 also 0. Correct or not?
Yes, sir.
Now, 1 time derivative of z is 1 factorial. 2 times derivative of z square, 2z 2 factorial. 3 times derivative of z cube, 3z square, 6z 6 means 3 factorial. 4 times derivative of z power 4 factorial. We are finding 14 times differentiation of z power 14. What is 14 times differentiation of z power 14?
14 factorial. That's it.
that is okay na?
Yes, sir.
Next,
then
next to one time.
Then set raise. Sir, then set raise to 15 we are taking individually, right?
Pardon? Next to?
No, sir. Sir, you continue, sir.
Wait. Next to this second step, you should know, right?
Yes, sir.
Next to 14 times the differentiation of z power 15 we know, right? We need.
Yes, sir.
Now look here, one time derivative of z square, 2z, means 2 factorial z. 2 times the derivative of z cube, 3z square, 6z. 6 can be written as 3 factorial. 3 times the derivative of z power 4, 4z cube, 12z square, 24z. 24z is 4 factorial z. Look here, z square, 2 factorial into z. Z cube, 3 factorial into z. Z power 4, 4 factorial into z. Z power 5, 5 factorial into z. Z power 15, 15 factorial into z. Here, first time derivative of z square, second time derivative of z cube, third time derivative of z power 4, 14 times the derivative of z power 15. Here 1, 2, 2, 3, 3, 4, 4, 5, 14, 15. Sequential order. 15 factorial z, you understand or not?
Yes, sir, I understood.
15 factorial can now be written as 15 into 14 factorial.
Yes, sir.
Is it clear?
Yes, sir.
That's it, Amma? Any other?
Yes, sir. No, sir. Now it's clear.
Should I end the meeting? Nobody is there. Akansha, still you have any doubt? Akansha? Okay, students, I'm going to end the session. Hi sir, how are you? You are staying here? Yeah, right now, I mean, I just don't grab the we actually walk on to how to see how కాలేజ్ వాళ్ళు రూమ్ కాకుండా బయట టీమ్స్ అందరూ మైక్రోసాఫ్ట్ చాలా ఇంజనీరింగ్ కాలేజ్ మైక్రోసాఫ్ట్ టీమ్స్ అందరూ ప్రాబ్లమ్ వచ్చేసి ఇద్దరు టీమ్స్ ఆర్ యూ కెన్ షో యువర్ కెనాట్ బి ఫైండ్ ఇట్ మనం గూగుల్ చేసిన only one thing. Obviously, I don't know. Narayana College also my relative working. They are using Microsoft. That's the problem. She teaches general science subject. For that, no equations required. So that's fine for her. So next month, even class library, but only in the part of the I don't know, it is difficult to maintain. Without, see, sir is not giving me any incentive. You just like, okay. That would be sure. Yeah, I mean, like, okay,